Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at programming in Lisp, that introduction I gave was probably enough for you to go to the common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay. So I won't quite give the answer away right now, but I'll sort of talk about. I'll just show you this stuff and confuse you a little bit more. So I've got lambdas within lambdas on the left-hand side, lambdas within lambdas on the right-hand side. Okay, and the reason why I mentioned what is missing in Java Lisp is that the right-hand side is not going to quite work. Okay, because of something missing in Lisp right now, the Lisp we know. But first, before we look at that, tell me what's different between the left-hand side and right-hand side. They both have composed lambdas. What's the difference? Andrew?
On the right-hand side, the y is defined inside the upper lambda, and on the left-hand side, both the x and y are defined in the outer lambda.
Okay, so in the outer lambda, the x and y are defined. And so that's just variable naming, no? In the inner lambda.
It's going to be in a different scope if you have when you call the y in a different scope, it's going to use the x from the scope above it, I guess.
So in left-hand side? In the left-hand side, the x is going to be referring to which x? So there's two x uses, right? There's plus x and there's plus 1x. So the plus x is going to refer to which x?
Basically the one you're passing, or it's going to refer to the plus x is going to refer to the outer lambda.
Outer lambda, and inner one is going to, okay, that's fine. Yeah, Chris?
On the right side, the inner lambda is basically one of the functions of the original lambda itself, versus on the left side, it's kind of, the inner lambda is kind of being, I want to say, passed in as a parameter to the plus x.
Is it being passed in as a parameter? Nathan?
I think this is a problem that I ran into, that the x can be overwritten on the left side.
So you guys are getting too much into x's and y's. Just tell me the structure here. There's two kind of lambdas. What is the relationship with the two lambdas in the left-hand side and the relationship with the two lambdas on the right-hand side? In both cases, the inner lambda is being defined by the outer lambda. Right? It appears in the body of the outer lambda. What's the left one doing with the inner lambda? Evaluating it? What's the right-hand side doing with the inner lambda?
It's defining a new lambda with the x as input.
What does it do with the inner lambda? It defines it.
No, it just defines it. It defines it, and that would in fact return it, in which it would call itself again with 2 as the input. The same.
On the left-hand side, we define the inner lambda and we apply the inner lambda as part of the outer lambda's functionality.
Yes.
In the right-hand side, we define the inner lambda and what do we do with it? We return it. We don't return the result of applying the inner lambda. We return the inner lambda, which is then being applied to two different arguments. Right? So, the 1 and 2 get assigned to x and y, right? And then this becomes 1. Then we go and say, okay, I'm going to have a lambda that has its own parameter x, okay? And I'm going to pass to the lambda my y. which goes and gets assigned to x and computes plus 1 of that. That gets added to the x and we get the result. In this case, this guy says I'm lambda x, I take an argument x, I go and return the lambda without applying it. I take an argument, 2 gets assigned to x, it gets lambda y, returns it, and it's done. And then we're going and passing 3 to this lambda y. So in one case, the nesting, in one case, it's like what we were talking about. You know, you can just call a function, or you can take a function parameter and then call it, or you can return a function. So in the left-hand side, there's no function parameters. It's just calling the lambda and defining it. On the right-hand side, it returns a lambda, and then that return lambda is associated with its own parameter, and by that time, the outer lambda is done. Okay? And the problem occurs with what happens to the x that is in inner lambda. Okay? Or what happens to the x. And right now, our system cannot quite handle it. Okay? On the right-hand side. On the left-hand side, we can all do it. We can do it easily, right? I mean, you guys can run it in your interpreter. You can run both in your interpreter. But the scoping issue becomes an issue. Okay, so this is what we will try to learn. So on Tuesday, we will learn how to go in, firstly, what this does. Then, why it doesn't do what we wanted to do. And what can we add to make it do what we wanted to do. And that will go and lead finally to define. Okay? So this is what we came to last time, and this made some heads spin. So I'll go through this in a little more depth than I planned to. So we see here two expressions that are somewhat similar in the way they're constructed, and yet are very different. Okay, and this is what I kind of left you with last time. So what's in both cases, the reason they're similar is because there's lambda within lambdas. Okay, so that's why I say lambda composition. So how are they different? I mean, they compute different functions, but how are they in some higher way different? Say in some abstract way, how are they different? Andrew?
Wasn't it that the lambda on the right passes back the lambda function as opposed to evaluating the lambda function?
So there's the lambda on your right. So this is this the right lambda? No. This is the one? Okay, so that's my right too. Here. Okay, so this lambda does what again?
It passes back the lambda function that doesn't get evaluated because it's missing a fun call, I think.
Okay, so there's a fun call issue, but it's passing the lambda to what?
It's passing, or it's getting the 3, or it's getting the, it's getting the 3 for the x, and then it's pulling the lambda outside, but then it unscopes the x, I think, and you have to,
So there's this lambda, there's this lambda.
yeah.
So you're saying this lambda is different from this lambda in that,
The lambda on the left uses the inner lambda in its functionality.
okay, good. So it uses the inner lambda in its functionality, whereas this guy does what with the inner lambda? Passes it out, and what's the term for passing something out? Return. So it returns a lambda. So this one uses the inner lambda, it defines the lambda inside it, this defines the lambda inside it, so outer lambda defines an inner lambda in it in both cases. In one case, the defined inner lambda is also used, it's also applied. In this case it says I'm going to just return the lambda and let somebody else use it. So remember, with lambda, we can do two things. Lambda itself is an expression that has the lambda value, and that expression can be then applied to an argument to return another expression. So the lambda definition is an expression, and the lambda definition application is also another expression. So in this case, the returned value is from the outer lambda is the value returned by the inner lambda when it executes. And in this case, the outer lambda returns a lambda, which we then go and use with the argument 3, which we then apply later. So the return lambda is not a return to the interpreter. Before the interpreter finishes processing, it goes and applies that lambda. Okay, so let's do this in slow motion. We have an outer lambda here. We have an outer lambda here. Okay, outer lambda definition. In both cases, I'm starting with the lambda definitions. Okay, without application. In that lambda definition is another lambda definition, both cases. So far, similar and lambda compositions. Okay. In the left case, the outer lambda expression is bound to these arguments 1 and 2, so it's applied. Okay. In this case, also the outer lambda is used and bound to the argument. So far, also everything is similar. The difference is that the inner lambda application occurs within the outer lambda application. Okay, and in this case, in the right-hand case, the outer lambda application occurs on the lambda expression returned by the. So the inner lambda. The inner lambda application occurs after the outer lambda has evaluated. Okay, so in effect, second lambda and application is in body of first lambda. Second lambda without application is in body and is returned value of the first lambda. Okay, so the inner lambda and its application are in the left-hand side, left body, and here they are only the lambda body is. And final result is application of first lambda. Final result is application of return second lambda. Okay, so you return the inner lambda and the value is the application of that. Okay, so this you saw in first order in higher order functions the return values and funargs. They're somewhat similar in that they're higher order functions, and here again we see there's some similarity in the two cases. With returns and composition, with the two forms of composition, in one of which is a return. Okay, so you guys get the basic idea. We'll go through this in even slower motion when we trace it. Okay, questions so far? So now you said something about func call. Did I need a func call somewhere here? Sorry? You wouldn't because of parentheses? So I see on that, here's the syntax. When we go and call a function, we can say something like this, where f is an identifier atom, or f should be a lambda expression. So we are applying, the argument here is 3, right? Is this itself a lambda expression? It evaluates to a lambda expression. It is not a lambda expression. So you were right. We needed a func call. Okay, and where do we need the func call? There are 2 lambdas here. Which lambda has to be associated with the func call? We want to apply 3 to something that evaluates to a lambda expression. Okay, what evaluates to a lambda expression? The outer lambda or the inner lambda? Outer lambda. So just remember, this is the rules here. We can do func call with f if f has been bound to a lambda expression. We can do func call with g if g has been assigned to something that evaluates to a lambda expression. Or we can do func call directly to something that is a lambda expression. Okay? So we have to do a func call on the outer lambda, on the outer lambda, and get from it the inner lambda, which we then connect to the argument. Okay.
So I guess just in terms of like the numbers and the actual like math problems. So basically the inner lambda has this like the still has the subscope of the outer lambda, and so it keeps the value of x stored as 2. Is that how that would work?
You're getting really ahead here. I don't know what's going to happen here. I'm just telling you how it syntactically looks. You want to know what happens to the x. You know, how does the inner lambda get the value of x? We'll just figure it out. Okay? That's the whole point of this whole lecture. Okay? So we'll just have to figure that out, but you've kind of answered it. You said what it should do, but not what it actually does. Okay? But that is a big thing. I'm going to look at both of them. So just because both the nested if, the func call, and the returned one, the nested one I'll go a little quicker because you guys kind of know that. You know how lambdas work. The one on the right-hand side is kind of a new beast. And we're going to, it's not that you can't return lambdas. You know, you guys are doing that in first part 1 of assignment 3. It's just that you're returning lambdas with this funny x unbound, which I haven't, you know, which you haven't done so far. And that's going to be the question we'll try to answer. Okay, that's the next big thing, and that's the final big thing we're going to do in this whole thing. And it's going to make your head spin. Okay. Okay. So now that we've got the syntax right, we see that actually I should have done the following. I should have done func call in the right hand side rather than just put a nested lambda. Okay. So let's go and look at what we understand. What I shouldn't say what we understand. What we can understand based on what we know so far. Okay, what we know so far, you know, you have to apply properly, and so nested lambdas will still make your head spin a little bit. So let's go through there and see what's happening. Okay, so let's take the case that on the bottom you're going to see the whole expression, and we are going to just evaluate parts of it in the order in which they get evaluated. So the first thing that happens is, you know, Andrew goes through your expression and goes through an expression factory and creates an input S expression. Okay, so that's what we've done so far. And we are going to create the outer lambda atom. Okay, so we're going to create the outer lambda expression first before we apply it. That's the rule. Okay, and we're not going to evaluate it immediately. We're just going to create the lambda atom. And after creating the outer lambda atom, we have to go and evaluate the parameters, evaluate the arguments of it. Okay, and you could potentially do them in different orders because there's no dependency among them. But people tend to go left to right. So we've created the lambda atom. We're going to now evaluate the two arguments to it, and they're just atoms, so the evaluation is kind of boring. Okay. So what's going to happen next now? I've got the outer lambda atom. I've got the evaluated arguments. What happens next? What do we do? Yeah. So it has to be passed into the lambda, right? So what does passing exactly mean in terms of implementation? So passing is what you think of in terms of user. In terms of implementation, what happens? Andrew?
It will set x and y in the environment to 1 and 2.
So which environment?
The child environment.
So there's a child environment that has to be created?
Yeah.
So we have to push a new child environment, and then you have to set x and y to that. Okay? So this is the new child actions that you didn't have to trace in your exam. This is a new child step you'll probably have to trace at the final exam, so it's good. Okay, that you remember to it. So we have, as it turns out, in the global environment, before I did this, I had x assigned to 5 in the global environment. Okay, so now I create a new environment on top of the global environment, and in it I set x. I go left to right. So I have two formal parameters, x and y. I set x to 1. Okay. Then I set y to 2. Okay, and that's what passing in parameters means. Right. So I've got the environment set up. I've got the outer lambda atom. What do I do next now? Sorry? So, yes, you have to go to the inner lambda. And you go to the inner lambda because what triggers going to the inner lambda? So in general, if you have a lambda and you have the parameters that have been set in the environment, what do you do next with the inner with the lambda in general? You got a lambda atom, you've got the parameters, you first computed the lambda atom, then you went and evaluated the parameters. Now you went and assigned the parameters in the environment. What do you do next in a general in a lambda? So in general, a lambda has got some optional expressions, and then it's got a required expression, right? So what are you going to do? You're going to, so Andrew gives you the lambda atom, and lambda atom has what operations valid on it? You can get its argument names. That's how we went and bound the arguments to the values. What else can you do with the lambda object, lambda atom? Eval it. And that eval is going to go and evaluate the optional expressions and the required expression. It so happens there's only one expression, which is the inner lambda. So it's going to go and process the inner lambda and its application. Okay? So, So we haven't gone to the inner lambda because it's going to go to its body, and the required expression has got a plus x. Okay, so before it can call plus, it has to evaluate x. Evaluating x means looking up x, right? So it does the lookup, and now it's going to have to go and compute the application of the inner lambda. So to do that, it has to go and do the inner lambda creation, right? Now you've got an inner lambda atom, same process. Now for the inner lambda, and before you go and then you have to look up variable y in the outer lambda environment, because that is being passed as a parameter to the inner lambda. Okay, so we have to evaluate now the arguments of the inner lambda. The inner lambda arguments, the actual arguments. The actual argument is this variable y. It's not a literal. So we have to do something less boring than just go and return the value of the literal. We have to go and look up y, get its value, right? And then that value will be stored in the environment of the inner lambda. So, and bound to x. So the 2 here gets assigned to x here because I passed the variable y as the value of the x formal parameter. Okay? Questions? Okay?
Question. So where is x equals 5 from?
From before, I didn't show you that. In my global environment, I had set x equal to 5 before I called this function. I didn't show you that. So x, that is just some value that's lying around in the global environment, right? And so we see there are 3 levels of x here. I just wanted to make that, so I just didn't show you that. Okay. Other questions? So now we get to, and so what are we doing here now? We are in the process of evaluating this plus x at the outer level. that plus has not evaluated completely. We evaluated x. We have to figure out the second argument of this plus, and the second argument of plus is now resulting in another plus being evaluated with 1 and x. 1 is a boring thing that just returns whatever whatever its value is, and we go and look up x variable, and that is 2. Okay, so we do this lookup. And now we can go and evaluate the inner lambda completely, okay? And the inner lambda will return 3. The plus in the inner lambda will return 3, right? And we can now finish evaluating the outer lambda, and the outer lambda will return plus 2, 3, which is 5. Or is it 4? So I pass 1 as the first argument. Sorry. So it returns 1 plus 2, 3. And then 3. 1 plus 2 plus 1. Okay. Okay? Questions? This was the easy part. Okay, but this is the kind of tracing you might have to do in the final with new child. Okay. Now let's get into this guy. Okay. So we've got the input expression for the whole thing. We create the outer lambda as we did last time. Okay. And so the outer lambda has a parameter 2. We evaluate that as before. We assign that to a child environment, as we did before. We are doing the same kind of steps. Okay, and now this lambda is not doing a plus 1, 2 or anything. It's just returning that inner lambda. So we have to go and evaluate the inner lambda. Okay, and so we get the inner lambda, and we didn't even use. So there's something wrong here. Somehow the value 2 was never used. We assigned the value 2, but we just return the inner lambda. And now we go and evaluate, so I don't know why I said func call of returned lambda. The func call was only on the outer lambda, not in the inner lambda. So we start evaluate a return lambda application. So evaluate, and that 3 is put in a new environment, and this is now where things get maybe unintuitive. So indeed 3 will be assigned in the new scope created for the inner lambda. But what is its parent scope here? The global, sorry? So there is the global scope, there is the outer lambda scope, and there is the inner lambda scope. The outer lambda was executed and returned.
But then was the scope from the inner lambda made from the scope of the outer lambda?
It was made from the scope of the outer lambda, but is called from the global scope. That is the most important point I want to make here. The inner lambda was returned from the scope of the outer lambda, and in the first case, when we looked at the expression on the left, the outer lambda was the one that defined the inner lambda, and the outer lambda was the one that called the inner lambda. So the inner lambda's parent environment was, according to the rules we have defined so far, the calling parent's environment, which was the outer lambda environment. Here the outer lambda has terminated, is finished. It returns the value back to the global environment, and the global environment then goes and calls the inner lambda. And according to the rules we have so far, It is the global environment that is the parent environment of this inner lambda. Okay? This is where we need to kind of know what this function, how our interpreter works, rather than how this expression should be evaluated. And they are at odds right now. And the should is based on our intuition from other languages. So that's the story. And what we're going to get when we're going to look up x? Unbound x. Okay, the inner lambda refers to an x. That x was defined and it disappeared after the outer lambda, and now we are referring to an x that doesn't exist in either the scope created for the inner lambda or the global scope. Okay, that's what's going to happen with your interpreter today. And you can say the rules are bad, or you can change the interpreter. But that's what we get right now. Okay? Questions? Okay, that's because it's called from global scope. So what we see here is that we essentially have a tree of scopes here. We had the global scope, and on top of that one, we pushed the outer lambda scope, we returned back, and then we pushed another scope on top of it, and they both, the root of both is the global scope. Okay, and actually this empty is wrong because, this empty is right, because here I don't have x assigned to 5. Okay, I did it in different form. I wasn't trying to make that point. Okay. So what's going on here? Let's use some term. A lambda expression takes some parameters. It can use those parameters as you can refer to the parameters in its body, and then there are some variables that it can also use in its body that are not parameters. And these are variables that you would normally call global variables, and we'll call them free variables. Okay, because we'll see that free variable is a more general term than global variable. Okay, so the problem is that we have some free variables, and when you have free variables, they don't have a very exact meaning. Where do you get their values from? The parameters we know, they have to be the actual parameters should have the values of the formal parameters should have the values of the actual parameter. Okay, the free variables are creating some ambiguities. Okay, so variable referenced but not defined in a function definition is a free variable in general. Okay, and I said that's it's a more general concept than global variable. And hopefully, if there are free variables, you've done the responsible thing, and you've assigned the value to the free variable before calling the function. You have somehow bound these values, and in our current interpreter, that happens through assignments or set Q, like set Q and parameter passing. So I could have gone and passed, assigned to y5, in which case, if I do func call f2, I'll get the value. I'll get this environment here. Okay, y will be 5 in the global environment, and I'll get the value 7. Okay, so free variable in this case doesn't create any unintuitive result, and you get this value. Okay, so no confusion. Questions? What if I do this? I set QF to some lambda definition. At this point, y is not assigned any value. Now I go and assign to y5, and then I call func call f2. What do you think will happen, and what do you think should happen according to your intuition?
I feel like it should, because I don't think x or y gets evaluated on the inside of the lambda.
So you feel what? You feel it should give an unbound error, or it should give?
I think that should work.
It should work.
Like, I don't think it's going to evaluate x and y on the inside of the lambda.
Right. So it doesn't evaluate x and y when you define the lambda.
And so then when you define y, it's still the global. And so when you define calling x, it'll still look at the global to see the y, I think.
Okay. So y has been set by the time y is needed.
Actually, no, it probably would crash because the global copy it has. Yeah, the copy of the subdepartment it has won't have y register yet, so it would crash because of that.
So they say you're not smart enough if you can't argue both ways. So clearly you're smart here. You're arguing both ways. So the first argument was, look, by the time y is needed to set. The second argument is that, hey, we freeze the environment, global environment, when we define the lambda, and that frozen environment is used in the evaluation. Okay, so he's given you both arguments. The interpreter is going to return one of these values. It can't do both. Any way to resolve the tie? Somebody want to be or not to be?
I don't know. I feel like if it didn't find anything, it was set in the child environment it creates, it would just look in the global parent environment and find y.
You think his first instincts were right. By the way, guys, when you write your exams, typically your first instincts are right. I've seen that often. You scratch something and you write something else, and when I'm in a nice mood, and normally I am, I look at what you scratched and give you points for having thought correctly the first time. So that typically happens. Okay. So we haven't done any. Andrew has an operation called copy, and remember long time ago we talked about deep copy, shallow copy, and just passing references. We haven't done any deep copying so far. Okay. When we saw ML, we saw there was a notion of deep copy there. Okay. But and we will give you an option at some point to do deep copies too. But in fact, the first argument was correct, that it may not be intuitive, but it's correct. Okay, that by the time y is needed, your environment has got y in it. That is when you go and look at it. Okay, and you'll get indeed 7. Okay, no problems. Might be unintuitive, but it works. Okay. So even in a Java-like language, when there's a global variable and a function defined that refers to the global variable, it is the most current value of the global variable that is used, right? Not unless it's a final variable, it's not the value that existed. The only difference here is that you create and assign the value later. That's why it's causing confusion. There, the global variable is declared earlier and assigned later. Here, the global variable is created after the definition, because it's all done sort of through an interpreter. So that is why things are a little confusing. Yeah.
Would it kind of be like a method, before you call like the method you're doing, you would define the mode, even though you already created the method?
So I'm not sure. You speak a little louder, but I'm trying to understand what you said. So in general, there are free variables that whose values don't know, right? So your question is that, say that again, a little louder.
I'm saying, like, can you compare it to like a method where you can create like a function that you don't have to know what you're going to pass in until you're actually going to call it?
So if you don't know what you're going to pass in, it should be a parameter, right? So this is really, free variables are not very nice. Okay? And you should really have defined that as a parameter. But you're being lazy. That's often people define global variables because they're being lazy. So they say, oh, I'll just go and, why define yet another parameter? People don't want to define in general. They want to define new classes. They want to define new methods. They don't want to define new parameters. There's this, constant battle between, clarity and laziness. And I'll say laziness in the short term. In the long term, you always get, I believe, hurt by being short-term lazy. I mean, that's the general rule in life, right? So yeah, you should have, but here we haven't done that, and I'll show you a little later how you're being even more, how you're being insidiously lazy in the next example. Okay? What do you think is going to happen here? There is no y in the global environment when I define my lambda. There will never be a y in the global environment. Okay? But I create after that a function called g, which has a parameter called y. Okay? And and that G goes and calls f and passes to it its y as the parameter that's bound to f's x. Okay? And then I go and say a function called G2. So let's go and get clear what we're doing. I defined a function with a parameter x and a free variable y. Then I defined a function g with a parameter called y that calls that function and passes its y as the value of the x in the f. And then I go and call g. G takes one parameter. G has no free variables, and I make y be 2, which makes x be 2 in f. What should happen? What should happen and what will happen? What should happen according to your instincts and what will happen? Okay, Nathan hasn't said anything so far, so I'll give Nathan a chance.
So what will happen is it does not have an environment of a variable y yet, but it does have a variable y in its main environment. So when it calls func call f, it makes a child environment copying that y still, keeping the y in the parent environment. And then when it tries to evaluate it, the lambda f, it will the lookup function will look for a variable named y, doesn't exist, so it checks with the parent, and the parent has a y, so it puts in that one. So it will use the y that we previously defined as.
Okay, so the y doesn't exist in the child's environment, the child is f. F's parent is the caller of f. The caller of f has a y. I'll find the y. Like it? You want to be lazy? No parameter passing? Just say that, I'll be called by a function that has a y. We'll just name y's consistently. And it'll all work out nicely. If it doesn't, you deserve it. That's always a thing. Whenever you want to be tricky, want to drive without seat belts, something bad happens, you deserve it, right? When people complain about Java and say, oh, it makes me do all these things, check everything, like flying an airplane, right? You go through 15 minutes of checklist before you can take off. Okay, there's a reason why Java does that. So, this is the situation that Nathan said, that y became x in f's environment, but y remained y in the parent environment. And when plus xy was called, we had the values of both variables, and we will get 2 and 2 before. Okay? So what's really happening here is that this is why I said, free variables is a general notion of global variables is a static scoping thing. Okay, that somehow your parent scope is one that's looked up. Here, the free variable is being used in a dynamic scope. That your parent environment happens to be your calling environment. And so that's what we're seeing here, dynamic scoping. This is what we've defined so far. So you look up the values either in your environment, okay? And if you just look up in your environment, things are very clear. When variables are free and not in your environment, then it becomes, where do you go? Do you go to the calling environment, or do you go to the, what's the opposite of calling environment? What's a term that you could use? Yeah, so the callee environment has got no problems. The callee's environment, if it has the value, we have no problem. But indeed, callee is an opposite of caller in dynamic. But the opposite of caller's environment is kind of what Andrew said much earlier in the class. When you're looking at the inner lambda, the x was in the, when we looked at the right hand side, when the lambda was being returned, The X was not in the caller's environment, but it was in the environment of the outer lambda. The outer lambda was the environment that defined the inner lambda. So it's caller's environment versus the, say it louder, defining environment. The static and dynamic environment versus the opposite of dynamic is static, or also called lexical by the JavaScript people and the C Lisp people. Okay, so that is what we'll be looking at right now. Okay, that the alternative is and what we've seen so far in other languages is static scoping and lexical environment. Okay. And I said, if things go wrong, you deserve it. This is how things can go wrong. The definer of G decided to call his variable X and not Y. They were supposed to call it Y to make it all work, but they didn't follow the rules. Okay? And now you will get an unbound Y. Was it unbound Y or X? It's unbound Y. Okay? So the naming conventions were not followed here. Okay, now naming conventions now are indeed a big deal. You see in Java naming conventions being followed, but you see here how they can result in some runtime problems. In Java, they'll be caught at compile time. Okay. Questions? Okay. So this is why the right hand side one was unintuitive. Okay, because we were expecting the X to have been taken from the callers and from the defining environment, and the defining environment was just lost after the definer returned. Okay, so I think I've got other slides that expand on this, but how would you fix this problem? Let's say you want this right hand side to work. Okay, how would you change your interpreter? So we have the outer lambda. The outer lambda had an environment at one time that had an X in it. The outer lambda returned, and the inner lambda was called from the global environment and became the parent environment. How could we somehow use the X that used to be in the outer lambda environment? How would we change? Yes?
So before the outer lambda finish the evaluation, we can set the parameter into the environment.
Okay. So somehow we have to save the outer lambda environment, right? That's one principle. And now the question is, where would you save it?
Before the finish the evaluation.
So that is what saving means. Okay, saving means that we save it before we finish evaluation, right? In Java, the environment is saved as long as you have a reference, so we're not really popping it. But where do we save it, Andrew?
So you have the global environment, and then you have the outer one as a child of it, and then you make the inner one the child of the outer lambda. So then I can look at the parent to see the X value.
Okay, so you're saying we have a global environment that's globally available. Yeah. We have now this inner lambda environment that was created while evaluating that lambda, right? It's not stored in any table. Okay. So we have the outer lambda's environment, go to save it, and you said we save it where? In some global variable?
Basically, we would be able to save like the outer lambda's environment by making it the parent of the inner lambda, because then it can reference the...
Okay, so we make it the parent of the inner lambda. So, but inner lambda gets a parent when it's called, right? So you want to just rephrase what you just said. You're right, that we have to somehow associate. What you want to say is that we want to associate the inner lambda with that environment, not make it the parent. Because parent gets made when when it's called. Okay, the parent is the calling parent. So we want to save with the inner lambda, with the returned lambda, the environment that returned it. The environment of the scope that returned it. Okay? Right? You guys buy that? Does that make sense? Okay. And anybody seen this concept in JavaScript or yes? What is it called? Scope chain. So, so I don't know JavaScript very well. So how do I know that it's called closure? Because I know the word closure exists in other languages. So I was going to the coffee room to discuss some hot water, and there was a kid interviewing with some company, and I could hear the interviewer and him talking. The interviewer says, "What is a closure in JavaScript?" Within 2 seconds I came back and had moved to another question. What is the difference between deadlock and live lock? Which also he didn't answer. And I'm thinking, you could have taken 524 and 533 and got your job. So I figured that JavaScript has closures, and that's exactly what a closure is. A closure is a function definition that's associated with an environment. Okay, and someday you guys might be interviewing, or more importantly, some days you guys might be the ones being interviewed or the ones interviewing. If you're interviewing, at least you can ask this question with more authority than probably that person did because you would have implemented closures. Okay, so that's what we want to do. Okay, so I think I've gotten to the crux of the matter. I think I'm going to go into it gradually now. So we gives an error. So what we have here is that we give an error when we may not expect it to. Okay, and so this is the intuitive versus non-intuitive. That on the right hand side we expect errors and we don't get them. Okay, because we don't expect that y's value to be used. We expect somebody to be saying that, hey, you shouldn't be relying on the caller naming the variable the way you expect it to. That's what we expect from history. And so what are the rules for intuitive versus unintuitive? So this is where we are getting it, going to the rules, that when you have a free variable, do you look it up in calling parents environment, or do you look it up in defining parents environment? Okay, so we've already seen this before. This is just articulating it in text. Okay, so that's the static or lexical versus dynamic scoping. And again, I mentioned this earlier. I've seen in Piazza discussion of lexical versus dynamic scope. And even with dynamic scopes, somehow this was intuitive. So sometimes dynamic scope was intuitive, sometimes it was not intuitive. So when was the dynamic scope intuitive? What was the conditions under which the dynamic scope was intuitive? We never got confused about the left-hand side evaluations, right? Even though we were using dynamic scoping. So are dynamic scoping and static scoping always going to return different results?
Was it more intuitive because it wasn't using high order?
Yeah. This is not using higher order function either, right?
But it's still returning the lambda expression.
But it's not using higher order. Using lambda expressions are not higher order. That's doing first order. The difference between static and dynamic environment is the parent environment, right? In one case it's a defining environment, one case a calling environment. They will return the same results when the defining environment is the calling environment. There's nothing to prevent the defining environment from being the calling environment. Okay, so that's when they will be intuitive. Okay, And indeed with higher order, when you have function returns, that is when the problem can occur. But you can also have problems when you're called by a function that overrides the variable in the global environment, in the defining environment. So calling environment, so it's intuitive when calling environment is the same as defining environment, it's unintuitive when they're different. Okay? So, as it turns out, all this unintuitive stuff doesn't happen in C-Lisp. It happened in the Lisp I learned. It doesn't happen in C-Lisp. They just always create that use of lexical scoping. Okay? And what we will do is we'll keep dynamic scoping, just so we understand that, and we will add static scoping to our interpreter. We won't replace it. If you really want dynamic scoping, you want to be lazy about defining parameters, go ahead. But we will also give you static scoping. Okay? And we need a new abstraction and we need syntax for it. So this is what we will do. We'll enclose a lambda expression within a function expression. Okay? A function expression has the first the keyword as function, not funcall, and the second argument is the lambda expression, and that's just telling it, hey, associate your lambda with the environment, current environment. That's all it's doing. Okay, we've already seen that we need to associate a lambda with an environment. We won't store it in the lambda. Lambda doesn't have a slot for the environment. We'll create a function object, a function atom, that has within it a lambda atom and the environment of definition of the lambda environment. Okay? And then when we do a func call, we'll go and make sure we use, if it's a func call to a function, then we'll use the defining environment. Otherwise, if it's a func call to a lambda, we'll use the calling environment. That's the basic idea. Okay? And that's, a function is a closure. Okay? This function atom is a closure in function programming. Okay? So I've gone in, I don't have to always use functions whenever I use a lambda. I've used a function only when I want the static scoping. Okay? So now my examples are, I set qf function, I do a func call, I can do a func call on something that's a function or a lambda, and they should both work. Okay? And when the static environment and the dynamic environment are same, they return the same thing. So we saw on the left hand side that this will return so now I've gone and set q y to 5 after the defining environment has been after the function definition. So we know what's going to happen here. What do you think is going to happen now with function? So now I set q f to a function, okay, and the lambda is supposed to have the defining environment, and then I create y later, and I set q y later, and I do a func call f2. Should I get an unbound error on the right hand side now? Chris, are you deciding to? Are you going to answer? You got your hand like, okay. Now static scoping is causing you guys confusion. So when I store the environment, the question is, do I store a reference to the environment, defining environment, or do I store a copy of the defining environment? And I guess we haven't answered that. That's why you're confused. But what should we do? If we store a copy, then we can't change the variables afterwards. So we are less flexible than Java. So we store a reference for now. And if we store a reference, will the right-hand side work or not? It will work, right? The defining environment is the calling environment, so it should give the same result. Okay? We could change the semantics to be more ML-like and create a copy, but we are not doing it. Okay? So which environment to choose decided on definition time. Not what the environment is. We're just choosing which environment to look at. That environment itself is dynamic. It can change. You can do set queues to add variables to it, change variables in it. And those are the values that will be used when the function is called. Just as when the global variable changes, a function can return different values. Okay. And this is, even though we're talking of a functional programming language, whenever you have free variables, you have side effects, and side effects are just considered bad. So, in a sense, you're getting confused, and the reason you're getting confused is because side effects are bad. Getting confused is bad, and side effects are bad. Okay, but they may allow us to be lazy. Okay. Yeah. Yes, because we did it from the global environment. Sorry? Having a lambda being called to a function, in here it doesn't make a difference because the environments are the same. Yeah. But now see the difference. On the left hand side we know it worked. 2 and 2 was 4. On the right hand side we created a func call. We created a function. And that function is bound to the global environment at that time. So what's going to happen when we evaluate G2, func call G2? We're going to evaluate F. F is going to create a new child, which is a new child in the defining environment, not in the calling environment. And does the defining environment have Y? Okay. Questions? Yeah.
So just to make this clear, so every time you use the function, you're just basically calling it in the static or the global environment? Is that what you're using?
Defining environment. When we have functions returned from other functions, there can be, it's not the global. And we'll see let later, which will create new lexical environments. So you can get deeply nested defining environments also. Just as you can get deeply nested environments in other languages. Okay, you have the class environment, you have the method environment, you have blocks within methods. Okay, you have blocks within blocks within blocks. So you have a whole hierarchy of static environments. We can do the same thing in Lisp. Or at least the new Lisp and C Lisp. There was a pure Lisp like I learned decades ago, and the one that I'm seeing today. Okay. And we come here now. So on the left hand side, this was, when we did the dynamic, this didn't work. Now this is going to work because we stored the parent static environment. That static environment has the value of x, so we're going to get 5 here. Okay, so finally, we get what you want, what you expected at the start. Questions? So this is pretty much the deepest we're going to go in this course. Okay, so things, once you understand this, it's, yeah.
So we said the parameter of phone call should be a lambda before. So now the parameter of phone call is a function.
Or a lambda. Yeah, or a lambda. So now you have to go and implement, so since you're into that, you want to change your interpreter to support this. So what all things do we need to support? We know that we have to go and associate a lambda with an environment. So do you need a new evaluator? Do you need to change your eval method in your expression? So do we need a new evaluator firstly? Yes? For function. And do we need to change our eval in S expression? You just gave us the reason yes. Okay, the eval has to go and evaluate both function expressions. So func call has to change, func call has to change, not eval. Because we'll handle that in func call. Func call will have to now assume both lambda and function. Yeah.
Will functions be able to execute like lambdas just as like raw lambdas?
In fact, in C Lisp, whenever you say lambda, it creates a function. It forces a function around. That's why you see, if you notice, you type a lambda expression, it comes back with function. Okay, it just said, just made a decision, which I like. Okay, but that's inconsistent with good old Lisp. Okay, so I got a little typo with extra G there. But now we see that we have a chain in that nested lambda, return lambda thing, we have a chain. We don't have the tree because we use the global defining environment. So now the question is, how do we implement static environment? And my animations, okay. So let's go and see. When we had just lambda expressions, we registered a lambda evaluator. Okay. When we went and did a func call around it, we registered a func call evaluator. Okay. Now I'm allowing functions also. So I need a function evaluator. And I do a func call on function too. So to change my func call evaluator. Okay. So that's, so we're getting into the details of what we have to do. Okay, questions? And we have to, I guess, also change. Yeah, so this is something that we do in our interpreter, but not C Lisp doesn't do it. So we also have to do this. We can also, without func call, just input the function expression directly. We'll allow that. So we will allow this case also, that S is equal to F dot where F is a function expression. Okay. And to do that, we'll also have to change our evaluation of the S expression. So we'll allow something like this, that without a func call, just go and type function lambda and apply it. We'll be able to go and call the function. Just as we do lambda application, we can do a function application. Okay. And when I tried it in C Lisp, so must change composite S expression evaluation to detect and handle new case. And so this is inconsistent with C Lisp, but we will allow that too. Okay. So, let's go and see how we have to change. So, this is what we did with the lambda evaluator. We said lambda factory new instance. We go and give the parameters, the body, and it returned the lambda. Okay, that was returned by lambda factory. Now we don't quite know what the function factory does, so let's go and imagine there is a function factory, and now I'm asked to go and evaluate So now I've got function, and within function I've got a lambda expression. And so that is my S, and we have been told to evaluate S. And so what should the function evaluator do? Read that. Remember the difference between function and lambda? What do we do? Why did we create function? Because it's a closure. So what should it really do? What do we really want done at this point? So we want to basically call a function factory and give it the environment to store. Okay? So we'll create the lambda first. Okay? And okay, so that was a hanging. And then we'll go and say return function factory.new instance lambda and environment. Right? So you didn't quite know how to answer that. We don't know what function factory did, but this is what it makes sense. That we in the function object we'll go and store the environment with the lambda. So we do still use the lambda factory here, and we just bind them together. So I have these, I think these things on the right here are just vestigial stuff that I had earlier. So let's go and look now at our function help, lambda helper versus function helper. So let's go and look at the lambda helper again. We created a child environment, which was environment.newChild, P1, P2, and then so then we go and get the arg names from lambda, okay, and we go and store the arg names with the evaluated expressions, right? So we have right now in the application, we have the actual parameters. We have to bind the actual parameters to the formal parameters. Before we do that, we have to store it, create a new child. Okay, the actual parameters we get from the lambda object. Sorry, formal parameters we get from the lambda object. The actual parameters we get from our input S expression. So we create a new child, and we go and store in the child environment, make this association, and we do a lambda.eval child environment. That's what we did earlier. Okay, now how does this change now? For function evaluate, for function helper, do we still have to go and call eval on a lambda? We still have to call eval on a lambda, right? That's the one that does the eval. So what's the difference? Here I went and said lambda.eval child environment. Do I still have to create a child environment? Do I still have to do a new child? Remember, the difference between lambda and function is in the free variables. The variables that are not free are put in a so given the environment and given your own parameters, you create where do you store the parameters? In a child environment. Right? You still want your parameters to override the defining parameter variables. So we still have to create a child environment. On the left hand side, we create a child of the calling environment. Now I have to create a child of the, and where do we get the defining environment from? Function. Okay? So somehow I have to go and create And we have the function right here, right? So we create a static environment, which is function.getEnvironment. We now say child environment is equal to static environment.new child, same basic step. And now we'll go and say so we still need the parameters to associate with the actual values. So I will go and create I will get the lambda from the function object. From the lambda, I'll get the arg names. Okay? And go and associate them in the child environment. And then now that I've got the environment all set up, I'll just say lambda dot eval child environment. Right? And if you want, and the question is, can we do this? This is a more succinct way of saying that. Actually, I can just use the lambda helper directly. Okay, so I'll just do lambda helper.eval. I'll give it the lambda it expects, okay, from the function object. And rather than giving it my environment, I give the lambda helper the environment I retrieve from the function. So this is a more succinct way of telling you exactly what's happening. Okay, so all that changes the environment. That environment I got from the function object. I have in the function object the lambda. So I can use that lambda eval and do this. Yeah.
Should we always use function when working with window?
Should you always use function when you're coding in Lisp? I'll tell you sometimes not to use it so that I can see the difference between function and lambda so that both are working. But in terms of programming principles, I would do it. Okay, C-List forces you to do it. But if you want to have real fun, you know, when you're doing programming, this class is not for serious programming in some sense, right? I mean, these languages are not the languages, they are sort of more researchy and more conceptual languages than sort of practical languages. So you can try to have fun and see what you can do with these things, okay? Because you're not, you're not using a practical language, you don't have to build a practical example either. That's why your Lisp interpreter is in Java, because that's a practical thing. But the programs you're writing in there, they're kind of fun programs. Okay? Okay, so this is where we'll end. And what we'll do next time is finish this up, do lets, and do something, if we have time, something called currying. Okay? And in your assignment, I'm going to make let and currying as extra credit features. Okay? So that you guys can just build up some extra credit too without doing extra credit assignments. Okay? I'm hoping I can do that by Thursday so that I can give that extra credit as part of assignment 3 itself. Maybe we'll do defun also. And defun is going to be very simple. Once we've studied all these concepts, defun is just straightforward. Okay? But I don't know if I'll cover defun by Thursday. If I don't cover defun by Thursday, that's not on assignment 3. It'll be on assignment 4. Okay? Okay, so the big deal last time and for a while now is the scoping issue. And we saw that there were two kinds of scoping, static and which was also called lexical versus dynamic. And the issue had to do with free variables. That you can have a lambda expression, you can have a body that references variables that are not its parameter, not the parameters. So it can reference variables that are free. And they have to be bound at some point you have to decide which variables from a set of variables that you may have as choices to take. And so dynamic scoping says that if they're not in your environment, not in your scope, go look up the environment of the caller, okay, the one who called you, because you're a lambda expression, you've been called, and that's when you've been asked to evaluate the body. And static scoping says when the lambda expression was defined, when the function definition took place, there was an environment of definition. Okay, and that's the static time in interpreter is kind of funny because in compiled languages, static is when at compile time and dynamic is execution time, but in interpreting environments, everything is dynamic. So we can talk of definition time and calling time. So when that expression was defined, at that point, what was the environment? And we'll go and use that for the free variables rather than the calling. Okay, so that's what's motivating. So dynamic scoping we already have, and the issue was last time was how to do static scoping. Okay, and we saw that we could just go and change lambdas to be static scoped. That's what Lisp does. What it implicitly does is that when you create a lambda, it puts it in a function call. But we want to make sure that we see all the choices that are available to us and understand them. So we don't do that automatically in our interpreter. So we have to explicitly go and enclose a lambda in a function expression. Okay, so just as we have lambda expressions, we can talk of function expressions. And a function expression is just basically a function followed by a lambda expression. Okay, and that yields a function expression. Okay, and such an expression is also called a closure. It's got many terms. In statically typed language, from what I remember, it was called a thunk, which I'll have to go and Google and see what it really meant. But these are very important concepts, as I mentioned last time. They're in other languages too, like JavaScript we mentioned last time. Okay, so that's what we've done syntactically. We've enclosed whenever we want something to be statically bound, lambda to be statically bound, we've enclosed in function. Okay, so on the left hand side we haven't done any enclosing. On the right hand side we've done the enclosing. Okay, so that's syntactically, and semantically we are supposed to use the static environment when we've done the functioning. Okay, and let's just go and see the difference in behavior. We saw it last time. Let's recap that. So we see f on the left being bound to a lambda, and the body of the lambda is evaluating plus xy, and x is a parameter, which means y, and y is not, so y must be a free variable. And we don't have to evaluate it immediately. We go and define another function g that goes and that defines ay and makes it y be the x parameter of f. Okay, so it's kind of confusing in that sense. And then we do func call g with 2. Okay, when we do func call g with 2, we set up an environment for g, it's a scope for g in which y is bound to a value. That becomes the parent environment of the call to f, and y is indeed found in that parent environment. So on the left hand side we get no problems. Okay, on the right hand side we enclose that in our plus xy lambda is enclosed in function. Okay, so y is still a free variable, but we've said that y should be bound to the static environment. If we were to do a set q y at the top level, this function would behave properly, but we don't do that. We again do the same set q g and do func call g2, and since we didn't do set q at the global level, when we go and call function f, y is unbound. Okay, so we get the answer 4 here, and we get an unbound y error here. Okay, and this is probably an error that we should get if we are used to static scoping, and if we're used to dynamic scoping, then we should do what's on the left. And we can, like I said last time, there are all these trade-offs you make in programming, and a lot of these trade-offs have to do with extra work you have to do to declare things. And with dynamic scoping, certain things don't have to be declared as parameters. You can just assume people use constant same names for y. Y is the y coordinate, for instance, and everybody uses the term y. So why go and make y a parameter? Okay, so we can make it a global a free variable. Okay, that's the same kind of logic we use when we create objects in Java, that we often create some things as instance variables that are shared among all the functions and methods rather than going and passing the value as a parameter. Okay. So questions about this? Yeah.
So in a dynamic environment, doing set Q, or this might be by the way. In a dynamic environment, doing set Q within a lambda.
Okay, set Q within lambdas are banned in our class so far. We said that when we did the lambdas, set Qs within lambdas are banned. So it's only right on the globe. We'll go to it later, but it was not in my original Lisp, and I can never kind of figure out what Lisp really does with set Q of lambdas intuitively. So there is a rule. We'll go and give you extra credit for doing it, but we don't do that. Yeah. But the main point is whatever set Q does, who knows what it does? If it influences the dynamic environment, so after set Q,
So outside the lambda, like that's why it works, because I set Q globally with Y exists.
because it's in the outer scope.
Yeah.
So that's the whole point, that I'm going to look up my static environment, and that is where the counterintuitive part comes in here, that static environment is bound, not the variables in it. In a Java-like language, when you define a function like this, we expect the X to have been defined already in the global environment, and then can initialize later. Here, the environment is set. We talked about that last time, but the variables in it have not been set, and those variables and their values will be looked up at runtime, even in static. I mean, that's the example. I've not reproduced the example from last time, but that's exactly what we saw last time. Okay. And then we saw another example where this is more common in Lisp, where you're returning a function, and on the left-hand side we're returning a lambda without a function enclosing it, and on the right-hand side we are returning a lambda with a function in a function call, and the return function takes a parameter x, but it's got y as unbound, and there is no y defined in the enclosing lambda, but there could be a y defined at some point in the global environment. And on the right hand side we have, sorry, I got this confused. So there is a y in the inner lambda, which is referencing we're doing plus xy, and the x is a free variable in the inner lambda, but it's a parameter of the outer lambda. Okay, so this is not the same case as last time. So on the and on the right hand side, same situation. So when we go and do dynamic environment, even though there was an x defined in a clearing environment, it will not be referenced because there is no set qx in the global environment. We will get an unbound error, whereas on the right hand side, since there was an x in the defining environment, that will be preserved somehow and will be used as the value of the free variable. Okay, so we get an unbound y error on the left, and we get the right result on the right. Okay, so again, different example, same concept, that we're using static versus dynamic. Okay, questions? Okay, so this is something we went through before, and if you're having trouble understanding, you can sort of pore over it. So now let's get into implementation. So we have the lambda operator, and we've now added a function operator. So the lambda operator and the function operator are related. So it's useful to go and see what we did with the lambda operator to understand what we wanted with the function operator. So when we added the lambda operator, we had to worry about defining a lambda evaluator. Now we have to define a function evaluator. When we added a lambda operator, we also allowed func calls then, and the func call had to worry about the lambda evaluator. So we are now going to allow func call to, so it's with functions also. So our func call evaluator from before has to change to handle both lambda invocations and function invocations. Okay, so this is the in your assignment 3, that's something you have to worry about. Okay? And we did a lot of it, how this implementation goes last time. We're just reviewing it right now, and we're going to finish it. Okay? So then we don't have to use funcall to call a lambda. We can just go and say lambda and parameters. Okay, so we can use the lambda expression directly. So we have to worry. So that means we have to in the S expression evaluator, we have to worry about what happens if what we're trying to the S expression we're trying to evaluate its head happens to be a lambda expression rather than a plus or some other predefined operator. Now, C-Lisp doesn't allow you to do directly a call in which the function function expression is the first argument, but we're going to let you do that. So we're going to have to go and change our S expression evaluator to handle the case when S expression's head happens to be a function expression. Okay? So those are the things we have to change. We're going through the implementation gradually, trying to see how it relates to lambda first, and what all things we have to change before we actually make the change. Okay, so we understand things better. Questions so far? So these are all steps you have to take for your assignment 3. And so our lambda evaluator just delegated most of its work to Andrew's factory. And what it did was it went and figured out what the parameters were, what the body was, okay, separated these two things out and told the lambda factory to create a lambda object, which happened to be an atom object and which stored the argument names and the body. So symmetrically, we have now a function factory also. We don't want to duplicate all the work in the lambda with the lambdas. So we go and first create a lambda. We go and look at our what we've been passed. We know that function is followed by a lambda. So we go and use that lambda expression to create use the lambda factory to create a lambda first. Okay, so that we don't have to repeat all that work. And what is really a function? It's a lambda associated with an environment. That's what a closure is. It's a function definition with its environment. Normally function definitions just inherit the environment. Here we've gone and said, you know, when the function is called, that environment may have gone. So let's go and associate that with the environment. A pointer to the environment. We don't freeze, we don't copy the environment at that point because that would freeze the values. No, we allow the values to be changed dynamically. But we go and just go and pass a reference to the environment. So we've now got a function object which has got a lambda in it and the environment. And the lambda in turn has the body and the args. Okay, so we've reused that. Questions so far? Yeah.
For the lambda factory since that part we just replace that with the expression tail of
So, I mean, you know, I'm not getting into the tails and heads. This is not giving you the exact algorithms. But I'm just telling you what it has. It has those parameters. It somehow gets the parameters by doing heads and tails. Okay, and associates with that. So are you saying this is wrong, or there's a...
because the thing following the function is just a lambda expression. We can evaluate on that as expression to get that.
Probably, yes.
Not explicitly.
Yeah, you're right. You can probably just do that. You can go and... so that's another way of putting it. So this is a pseudo algorithm. This is not the exact algorithm, but indeed, you can probably be more efficient.
So if you now associate the reference of environment with the lambda expression, I don't quite understand why the set Q example is there.
What set Q example?
In the previous example, you're looking for the free variable x. It's not in the current environment, but it will be set in the later environment.
So when you're talking about the case when we were returning a function?
Yeah.
Returning a function. There was no set Q there, right?
So in the first pair of examples, you show the set Q is left and right. Then go back to the
I don't want to go back because I'll lose the recording. Okay? But I showed you two sets of examples. In one example, there was no set q of a global variable, free variable, and we got f got its y from g. Okay? There was no set q. In the second example, there was no set q either. Okay? There was a function that lambda that had an outer lambda that had an inner lambda. Inner lambda had a free variable called x or y, I forget which, x I guess. And that free variable was bound to the outer lambda x. Okay? When the outer lambda finishes execution, it returns the inner lambda. At that point, the inner lambda is called, and the inner lambda's calling environment doesn't have the outer lambda. The outer lambda's environment, the environment happens to be the global environment. So there is no x in there, so it fails. In the dynamic case, it succeeds in the static case. There were no set q's in either of my two examples, except for the function definitions. Okay, but we were not going and setting any of those free variables in the lambda expressions to anything. Okay, but indeed, if there is a set q in that environment that I've stored here, that set q's effect will be felt when we evaluate this lambda. That you are correct about. On the other hand, if I had done a deep copy of the environment, that set q's effect will not, the future set q's effect will not be felt when we evaluate the function. Okay? More questions? Okay, then in a lambda application, we had a lambda helper, okay, that was used both by func calls and by direct application of the lambda. Okay, so it makes sense to have a function helper here also. And we went through, last time and said, how does the function helper really differ from the lambda helper? And then once we've understood how it really differed, we could just go and reuse the function helper from lambda, the lambda helper to write the function helper. Okay, so this is what I'm doing here. This is kind of what Ruben was saying, that we're just reusing what has been done earlier. So the function helper says, if you give me a lambda, if you give me a set of expressions, and if you give me an environment, I'll go and find the arg names, okay, and I will go from the lambda. I will go and create a new scope. I will associate the arg names I will create a new scope on top of the environment I've been passed. I'll go and bind the arg names that I get from the lambda object to the actual parameters I've been given, and I'll evaluate them, and then I'll go and evaluate the body afterwards. I'll ask the lambda object to evaluate the body. So the only thing that differs now is that if we can figure out the lambda in the function, okay, which we can do, we can just go and do function.get lambda. We just have to go and pass a different environment to the lambda helper. Because lambda helper fortunately took the environment as parameterized. Rather than giving it a dynamic environment, we give it the static environment. That was the whole point of storing with the lambda the environment. So this is where we go and pass. This is where the static part happens. Okay, so that's the only difference. Questions? So now we have to also worry about the direct application of the function rather than through a func call. So what we do earlier was that we go and look at the head of the call, do an eval on it, get the lambda, and then do lambda helper.eval lambda. So what are we going to do now? We've been given a func input. So I did lambda input.eval to get a lambda, and now what will I do? If I do a func input.eval, what will I get? Can I do a func input.eval? Have we seen enough stuff to figure out how to evaluate something that is a function expression? So what's a closure? A closure is a lambda associated with an environment. And how did we get the closure?
With the environment in the function factor.
Right. So we put that in. And what were we evaluating at that point?
I was just evaluating. I was just creating a function, so it was just evaluating a function call.
A function call, a function expression, which is what this func input is. So guess what? What a complicated piece of code here that seemed to astound all of you. Func input.eval gives you function. That's what we were getting, that we defined a function object. Okay? And now we got a function helper.eval, function E1, E2, environment. Okay? And the function helper is just going to use the functions environment rather than the actual dynamic environment. So that's where we see the difference. Okay? Okay. So let's also get this in our head right now. I mean, there's a lot of, when you do prove a theorem, there's a lot of lemmas, and you have to keep track of all the lemmas to prove the theorem, and that's kind of what's happening here. That all the pieces, haven't quite sunk into you, and that's why implementation is good. So, when we do an eval, when we do func call, so far what we've been doing is we've been assuming f happens to be, we check if f happens to be a lambda expression. If f happens to be a lambda expression, we go and do lambda equals f.eval and do lambda helper.eval lambda da 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 da. Now we are given a situation where the func call f can be a lambda expression or a function expression. Okay, so what should we do? Again, this is not hard. What should we do with f? Evaluate it, and what might we get? So on the left hand side, we always got a lambda back, if it was not a name. On the right hand side, we might get a lambda back, or we might get a function back. So all I have to do is I say lambda or function. Okay, and now I just check. Is it lambda? Do the lambda thing. If it's not, do the function helper. Okay. So this is also taken care of. Questions? Okay, so let's just consolidate, just go ahead, our understanding. So we did this nested call when we had lambda being returned. Now we are returning a closure of a function call, a function expression. Okay, and let's just go and see how things change. Okay, so we are given this particular expression to evaluate, and we create the outer lambda. We create the outer lambda first. Okay, so the outer lambda, whenever we create a lambda, we have to give its argument names of the body. The body happens to have a function in it, but we don't see it at this point. Okay, we're creating the outer lambda, and we just have got the body of the inner lambda, and we haven't looked into it. Okay, so that's what we've done first. We've created the outer lambda. That happens to be not a function call. We can mix both things. That just has no free variables, so we don't have to create a function. And we got the outer lambda. Now we can go and evaluate the outer arguments. So we eval that 2 to 2. And that 2 has to go somewhere. That goes in a new environment on top of the global environment. So x is assigned 2. So that's good. We've captured this value. And Then we evaluate the body of the main lambda, okay, and that involves creating first the inner lambda, okay. So that is what, before we can return the inner function, we have to compute the inner lambda. So we get the inner lambda, okay, and that inner lambda is then associated with the current environment in this new function. Okay, so the function factory does exactly what we saw earlier. It takes the inner lambda, associates with the current environment, we save it, okay, and we this is the one point where we diverge from what we did when we had no function call. Okay, so this is the step that's creating the closure. Okay, so now we are going to call the inner lambda. So we evaluate its arguments as before, and we have to go and create a new scope for this environment. We don't take the calling environment. We get the environment from the function, which we have stored. Okay, add this on top of that. Okay, and we don't get an error. Okay, so this is basically re-saying what I said earlier, but we're seeing that in an actual example. Any questions?